Hi. So today we are going to be taking a look at something a little bit different. So for this week, we have been looking at basically finding slopes, finding the equation of lines, things like that. Today, though, we're going to be taking a look at how different lines compare to each other. Specifically, we're going to be taking a look at something called parallel lines. So the basics of what parallel lines are, as you may remember from Unit 1 when we talked about parallel, is if I have this line here, and let me just make a copy of it real quick. These two lines are parallel. They are lines that keep going infinitely in both directions, but regardless of how far out they go, these two lines will never cross paths. Now, if I had tilted this just even slightly that direction, see how far it goes from that to that, just that slight change. They still look pretty similar, but this, it may take, I'd have to draw this line out for a few miles to get it to work, but eventually it would intersect with this one here. Now, obviously, if I did something like this, it's pretty easy to see they're going to intersect, and sometimes they can do that, but parallel lines never intersect. So we have been looking at the equations of lines. Specifically, we've looked at things that look like y equals mx plus b, which is our slope-intercept form. And we've also looked at y minus y1 equals m times x minus x1. And that's our point-slope form. These are both the equations of lines. So what we're going to do today is we're going to take a look at how to tell if two lines are parallel just by looking at their equations. So a little hint, all we care about right now are these numbers right here. And if you remember, m for both of these is the slope. Slope is our rate of change. It's our rise over run. It's how steep our hill is and what direction it's going to go. So this right here will tell us if they're parallel or perpendicular. Because if I were to, which I probably shouldn't have just gotten rid of it, but that's not a good line. If I were to bring back another set of lines, you see, this line right here is the same as this line. They're different lines, but they still have this. They still have the same slope. They're still increasing upwards at the same rate. So that means that they have the same rate of change. They're not going to intersect ever. So this lesson is actually really easy, to be honest, as long as you know where the slope is. So, for example, if I were to, excuse me, say that we have a line that has y equals 2 over 3x minus 4, okay? Then we had another equation that was y equals 2 over 3x plus 20. Those are definitely different lines, but are they parallel? Well, let's think about where the slope is. The slope is between the equal sign and the x. So 2/3. Are the slopes the same? Well, yeah, they're both 2 over 3. And that means that they are parallel. Excuse me, sorry. Now, there is an exception to this rule. For example, which I'll just borrow these real quick. So if, for example, let's just say that this second line, and I'll show you why in just a second. let's say I had two lines, y equals 2/3 x minus 4 and y equals 2/3 x minus 4. Are the slopes the same? Well, yeah, they have the same slope as last time, so they're both 2/3. So they're good in that regard. But if we look, these numbers here, those are the same too, aren't they? So let's just take a look at this for a second here. So if I gave you the equation y equals 2 or 3x minus 4, I can split it up. 2 or 3x minus 4. That's what that line looks like right there. And just for reference, we're taking a look at this at first, okay? And I also have this one over here. Y equals 2 over 3x plus 20. Now let's zoom out just a little bit. So there, we have these two lines, okay? Regardless of how far I zoom out, they get really close together, but they never overlap. There's always going to be a space between them. They're parallel, they never touch. Now, let's take a look at this set here where they both have the same last number. So if I go back over here and I replace this with a minus 4, well, it seems like that line disappeared, didn't it? Can I turn these off? If I turn off, you'll notice that when I turn these off, they overlap a little bit. So if I turn off the blue line, I saw the red line there in the same place. What that's saying is that these are the same line. So parallel lines can never intersect, but these are intersecting at every single point. Every point on one line is a point on the other. So these technically have a name. They're called, which I can do this, make it easier. They're called collinear. You may remember this from our first unit. Collinear lines are lines that are the same. So these can't be called parallel. But again, we're not focusing on this too much. I just want to make sure y'all saw an example of it. We're focusing on this. So basically, if the slopes are the same, they're parallel, with the exception of when the intercepts are the same as well. Now, technically speaking, I could just say line 1 has a slope of 4, and what is the slope of line 2? Okay, so if these are parallel, actually, you know what? Save you all from having to try and read that stuff. I am just going to use some typing. So if these two lines are parallel, and line 1 has a slope of 4, what should line 2 slope be? Well, if parallel slopes are the same, if this is a 4, that has to be a 4. There's no exceptions. Parallel lines have to have the same slope. They have to have the same slope because if they have the same slope, they increase at the same rate, so they'll always be the same distance apart. So let's see if we can find a good example. Basically, if I zoom in just a little bit, it makes it easier. This point right here is 0, -4. This point right here is 0, 20. These 2 points are 16 units away. Okay. Right here, this one is 18, and this one is 1832. Again, they are 16 units away. Doesn't matter how far, if I were to scroll way up here, we're in the really big numbers. Right here, 756, we have 870, 7056, and 870, 600. That's still 16 units apart. Parallel lines are consistent in that they will always be the same distance apart from each other. Doesn't matter where you draw. If I were to draw a line through here anywhere, it'd always be the same distance across. That's what's convenient. Well, that's what's unique about them. So they have that same slope. So it doesn't matter what kind of form I give you. If I were to do y minus 3 equals -7/8 times x plus 2, and then I gave you another line of y plus 3 equals -7/8 times x plus or minus 3 halves. Those are pretty different lines, but we look at the slope, and they're the same. Since the slopes are the same, they're parallel. Now, if you want, I can test it out to double check. So let's see what happens if I were to type these. I think I can do it in here. Y minus 3 is equal to -7/8 times x plus 2. All right. And then y plus 3 is equal to -7/8 times x minus 3/2. Oops. There we go. Okay. So those are our two lines from before. And if we take a look, they're parallel. The distance between them isn't as easy to figure out exactly, but they are parallel. Let's see, -1.68, 0.26. So about 2.948 apart. Yeah. Either way, they're parallel because they have the same slope. They'll never touch. And if we zoom out a lot, they stay the same distance. Eventually, the graph gets so small that you can't really see the space in between them, but they never intersect. And that's the basics of parallel lines. They have the same slope. So if you have a question asking about parallel lines, just remember parallel lines. If we go back to like thinking about sleds and all that, and sledding on a hill, which you may have been able to do because there was, at least down in McCray County, a decent amount of snow that fell the other day. If I were to start on this hill and slide down, I'd be going the same speed as this hill. They have the same slope. They're parallel. So when you think of parallel lines, just remember the same slope. That's all you have to remember. This is how you tell the difference between them. Parallel lines have the same slope. Tomorrow we'll look at what perpendicular lines are, but make sure you know this one. Because if you it's easy to get the two confused, but parallel lines have the same slope. They're parallel, the same distance. And if you have any questions, just holler.